Hello, everyone. We're delighted you're joining us for this session on optimizing generative AI and ML model development and training with AWS Storage Infrastructure. I'm John Mallory, a storage specialist focused on analytics and Gen AI ML workloads, and I'm joined today by my colleague, Laura Shepard.
Thanks, John. I'm Laura Shepard. And in this session, we're going to share what we and our AWS colleagues have learned from more than the 100,000 customers of all sizes and industries who are using AWS for AI/ML workloads. Specifically, we want to share how and where AWS storage infrastructure really makes a difference in accelerating your Gen AI/ML adoption and optimizing your Gen AI/ML workloads.
Great. And so I know there's a bunch of different personas in the audience, and many of you are familiar and are AI/ML experts, but we'd like to start with a quick level set on the different categories of AI/ML. Even though it feels shiny and new, AI has been around since the 50s and refers to simulations of human intelligence by computers using data and logic. Most AI cases look for probabilistic outcome. They make a prediction or a decision with a high degree of certainty, very similar to human judgment. Almost all AI systems today use machine learning, which uses large amounts of data to create and validate decision logic, which is known as a model. ML models use historical data as input to predict new output values and become more effective and accurate as you use larger data sets to train on. Diving down the stack, deep learning is a subset of ML that is based on our understanding of how the brain is structured and uses neural networks to perform complex tasks like speech and image recognition. This has been a big breakthrough and unlocked use cases like computer vision and speech recognition. And then finally, generative AI, the thing everyone's interested in today, is a subset of deep learning that is powered by large self-learning models that are pre-trained on vast amounts of data and commonly referred to as foundation models. And then finally, reinforcement learning trains models by using a reward function of a desired outcome. For example, this is how autonomous vehicles operate, and they usually require a simulation tool to train the model. But the key takeaway to all these categories is that AI/ML is built on data, and the more data you're able to select and use to train your models, the more accurate your models will become. So that's why we're here to tell you why storage is foundational to AI/ML. So what about Gen AI? Obviously, super hot topic today, taking the world by storm. And the reason it's so powerful is it can create new content and ideas, including conversations, storage, images, videos, music, even code. And it can do this because it's powered by types of ML models known as foundational models that are pre-trained on vast amounts and varieties of data, including text, image, and video. While the early focus of Gen AI has been on consumer-facing apps like ChatGPT, the real power is that they will allow businesses to offer innovative new experiences to their employees and customers and ways of utilizing their data that will transform how they operate. So huge upside with foundation models and Gen AI. So why have we seen Gen AI and FMs in the past couple of years? It really comes down to we've reached a tipping point that combines rapid advancements in ML technologies, the ability to cost-effectively collect and store massive amounts of data on cloud storage, and being able to make that data available at very high levels of performance to large clusters of elastic, powerful, accelerated compute capacity like GPU. All of these breakthroughs have made it affordable for businesses to do what could only previously be done in research labs with purpose-built massive supercomputer clusters. What makes FM special is that they can perform so many more tasks because they contain large numbers of parameters or variables that they can manipulate and are capable of unsupervised self-learning of complex concepts. Although their training exposes them to internet-scale data, they essentially can be applied to a wide range of contexts. So while foundational models, there's generally a kind of arms race on the number of parameters that are in them and the complexity, recent studies by things like DeepMind Chinchilla model have shown that smaller models with fewer parameters, but those that are trained with larger sets of well-curated data, can offer more accuracy than much larger models, which is going to make it more accessible to a lot of different businesses. And then finally, businesses can apply foundation models and essentially leverage all of the intelligence that's built into them, but then train them and customize them using their own much smaller data sets so that they don't have to spend all of the resources to train these large models, but they can still leverage them. And so at the end of the day, all AI ML models begin with data, and being able to train a model against a larger set of carefully selected and prepared historical data and more complex scenarios leads to better accuracy. So being able to cost-effectively centralize and retain data is key to successful AI ML, whether you're building traditional ML models or FMs. And really, data preparation is an important part of both types of models. So while you need to use labeled data for traditional models and FMs use unlabeled data, essentially the data curation and data preparation is very important. And a second key is that these models are typically built by collaborative teams who are using the same data assets and often sharing model artifacts. So secure data sharing and interaction is required. And then finally, training and utilizing models is an iterative process where you want to update models over time, blending newer data with previously utilized data sets and observations of how the model has performed over time, and leveraging ever-advancing ML technologies. And so essentially, being able to train and store more data is important. And then finally, for consumers, being able to securely use their own data to adapt and customize the models is key to store the models and then the data they're going to customize them with in their own VPCs. Finally, there's a retrospective element to this where people want to know what's gone into the models and be able to go back and audit this. And so archive and governance is also very important. So really, a modern data architecture can accelerate ML adoption. If you think about what you need to do to build a data lake, you need to integrate a lot of data sources, get them centralized, get them cataloged, cleansed, prepared, and governed. Then you need to bring the tools to the data and prepare the data, get it ready for use, consume the data, and then finally make it available to a bunch of different consumers in many different forms. This is called building a data pipeline, and it's very similar to what you need to do for machine learning. So essentially, if you have a data lake, it can greatly accelerate your ML journey. No matter whether it's traditional ML or generative AI, foundation models, machine learning follows a very similar lifestyle of prepare, build, train, and deploy. We're going to touch briefly on build, but really go deep on training today. And then AWS provides the services and infrastructure no matter where you are in your journey, whether it's pre-trained foundation models or services like recognition that you can just point at your data, or whether you're an advanced consumer and you want to train your own models, either using fully managed services like SageMaker or self-managed services like EC2, containers, compute, and open source frameworks. So, to kind of wrap up and, hand it off to Laura to go deeper, the storage requirements for AI ML training are easy data sharing and collaboration so that your teams can really, work together efficiently. You need to have highly scalable performance and be able to seamlessly scale this over time without having to lift and shift data to new platforms, because you want to future-proof as models get bigger, more complex, and more powerful compute comes in the pipeline. And finally, you need cost-effective storage so you can keep more of your historical data and model artifacts that make your models accurate, and then easily repurpose these for future training runs. So Laura, over to you.
Great. All right, thanks, John. So We have customers who are training exclusively on object and customers who are training exclusively on file. And we always try to understand, how they're thinking about the trade-offs between these two approaches for data sharing, for performance, and for cost, as John mentioned. And we have some of that consolidated experience to share with you here. So let's look at these trade-offs for each one at a time, starting with collaboration and sharing. So in collaboration and sharing, so object has these big strengths, right? Not the least of which are ease and scale for ingesting data, for example, from public data sources, and broad integration with other AWS services, and especially those that help with building, maintaining, and leveraging a data lake. And then File has strengths here too, right? So for collaboration and data sharing, File is compatible with virtually every ML tool, framework, and application. And data scientists and developers tend to be more familiar with a file interface, especially when they're interacting directly with data, such as when they're in the build phase of ML. So when we're looking at performance considerations, customers like that they can get this massive performance and scale from both object and file approaches. When that data is optimized for streaming, either because it's naturally large sequential I/O or because they add data transformation steps or batching to make their data behave like large sequential I/O. But for data that's not optimized for streaming, right, we see customers tend to build more with file, which is architected to handle random I/O more gracefully than other storage approaches. So to illustrate how customers solve this problem differently with different approaches, let's look at two customer examples, AI21 Labs and Netflix. So AI21 Labs, they build state-of-the-art language models, foundation models. And they and their customers then customize these models for use in their own products and services. Their biggest model is called Jurassic. They have a couple of versions, right, 1 and 2, and it has 178 billion parameters. They've chosen to build and train their models using Amazon SageMaker with their data on S3. And as you can see from the slide, they are happy with the performance and the cost of this approach. But our next customer takes a different approach, right? Netflix uses large-scale distributed training for their own ML media models, and then they use these models to generate thumbnails and trailers that you see when you're using their service. And they do this for thousands of videos and millions of clips. So in their training environment, they were using a lot of node local storage, right? NVMe and SSD to reduce the latency of access to data and have really high bandwidth. And this meant, of course, they needed to copy their data to that node local storage. So they were spending actually quite a bit of time doing that. And we're going to talk about that in a second. Because every time they brought in new assets, they had to copy them to local data. Every time they changed the compute configuration, they had to copy data to local. Every time they lost a node somewhere, they had to copy data to local. So this was actually costing them some time. They also discovered a little bit of inefficiency in their data loading pipeline. They discovered both of these things working backwards from CPU utilization, which is something we're going to be spending some time on today, right? So if your CPU utilization isn't high, that is not a great use of your investment, right? So this made them work backwards to find these two issues. And what they did was they changed their underlying storage platform to FSx for Lustre. And then they added pre-computing step in their data loading pipeline. And by doing these two things, they were able to increase the performance of their data training phase by 3 to 4x. So basically, they went from a week to 1 or 2 days to train their models. All right, and to round things out, let's take a look at the cost effectiveness advantages of both object and file. So now object storage cost effectiveness, that's pretty straightforward, right? Simply put, cost of capacity is hard to beat on object store, especially when you consider the many tiers that are available under S3 with different capabilities and costs. The cost effectiveness of file is less direct, but very important and even critical, especially for ML workloads like distributed machine learning training, where it can save a lot of money reducing the amount of compute needed per training job. And we just saw this right in the Netflix example. Since compute is by far the biggest investment in a training job using a different tier of storage, not necessarily as cost effective as object, but that can save a huge amount of the compute resources needed for the job, that can really save a lot of money. So we have been comparing and contrasting, right, the data sharing performance and cost strengths of object versus file. But as it turns out, you don't have to choose one or the other. So with Amazon FSx for Lustre, our fully managed high-performance shared file system, it is directly integrated with Amazon S3, so the two can be used together to deliver the best aspects of both. The pattern that we see customers taking is to store their data in S3 and then run compute against that data either in S3 or in FSx for Lustre, kind of depending on their requirements in each phase of their ML development lifecycle. So, for example, most commonly what we see is that data scientists who are hands-on with the data in the building phase, or the data which is maybe not necessarily streaming optimized in the training phase, or when the data sets in the inference phase are really, really large, the customer tends to work directly on file. And when none of these is the case, they tend to work directly against their data in S3. A great example of a customer who is using this great integration between FSx for Lustre and S3 is Toyota Research Institute. So they use an S3-backed FSx for Lustre file system for their autonomous vehicle development program. They use it for both their broader data science environment as well as specifically for ML training. So they're autonomous vehicles, they are taken for test drives. This might be on a closed track, it might be on the open road. The data collected is loaded from on-premises into their S3 data lake, and the S3 data lake is then their data of record. So when a data scientist creates a project to train a new model or to retrain an existing model, the training data is automatically made available from S3 via FSx for Lustre and connected to a powerful GPU compute cluster for the training phase. Page is another example of a customer who follows a similar pattern, right? They develop complex ML applications that support healthcare professionals in delivering precision diagnoses and treatment plans. So they're using ML to directly improve patient care and patient outcomes. I'll take a second on them because there's something very interesting, I think, which is because of their innovative approach to cancer detection, Page was actually the first company to get the US Food and Drug Administration's approval to use AI in the field of pathology. So anyway, they are using an S3-backed FSx for Lustre file system for their training to simply and easily train their models against over 10x the amount of data that they were able to using other approaches. So because they don't have to choose, Page, Toyota, and many others are able to leverage the best of both file and object infrastructure across their entire ML development lifecycle. So we hope that you'll stay tuned for the next session, which is called Run Compute-Heavy Workloads at Cloud Scale. In that session, we're going to be taking a deep dive in how you accelerate your HPC workloads with AWS Storage, including, among other things, a deep dive on FSx for Lustre, the file service, and the specifics of how it integrates directly with S3. So if you want any more detail on the topics we covered in this session, please check out the additional linked materials. And John and I thank you very much for your time.
Yeah, thank you. And thanks, Laura.